we are looking at solving quadratic equations, and we're going to focus mainly on three methods this lesson. So we're going to look at quadratic formula, completing the square, and factorising. If we have time to, we'll look at iteration, but it's a bit of a beast, so it's almost an entire video in itself to look at that. So let's look at the quadratic formula first. So what is it? It's basically the laziest of the three methods. So all we do is we take our quadratic formula, which is the thing in this box, and we plug our values into it. So for example, if we look at this example question, right, where we're solving for x, we've got 3x squared plus 5x plus 6 equals 0. And so, going by this standard layout of ax squared plus bx plus c, well, in this case, the number in front of x squared is 3, so a is 3. The number in front of x is 5, so b is going to be 5. And the number on its own, the constant, is going to be 6, so c is 6. And all we would do is we would put that into our formula. So we would say x is equal to minus b, so minus 5 plus or minus the square root of b squared, which is going to be 5 squared, minus 4 times a, which is 3, times c, which is 6. And that's all divided by 2a, so 2 times 3. And we could plug that into our calculator. One of the versions of this, we would use the plus version of the plus minus sign, and we would then go back and use the minus version of the minus sign. So we should be getting two solutions. We normally expect to get two solutions, which makes sense, right? Because if we look at the standard shape of a quadratic, it looks something like this. And so when we're solving for this quadratic equaling 0, well, we expect two solutions, right? Because it crosses 0 twice. It crosses it there and it crosses it there. If this is our y and our x-axis. So that is the quadratic formula. Next up, we are going to look at completing the square. This may be the more complex of the three. So there's a general rule which we're going to kind of derive as we go. So if we've got again, let's start off with an example. So let's say we've got x squared plus 6x plus 5 equals 0, and we want to complete the square on this. Well, what we can do is we kind of focus on the first two terms, right? We focus on the x squared and the x term. We almost kind of ignore the plus 5, the constant bit at the end. And what we do is we transform this into something that looks like this. And we take the number in front of x and we halve it, and we ignore the x squared. So x squared becomes x, and this number, in this case 6, halves to become 3. And then we square that. And you'll see why we do this in a second. And then obviously we've got that plus 5 equals 0. Well, why do we do this? What's the point? Well, let's look at what happens if we actually expanded these brackets. So if we take this x plus 3 squared and we actually expand it, well, this is just x plus 3 times x plus 3, which might make it slightly easier for anyone following along to understand what I'm doing next. So we're going to end up with x times x to get x squared. We're going to end up with x times 3 to get 3x. We're going to end up with 3 times x to get 3x. And finally, we're going to do 3 times 3 to get 9. Well, we know that 3x plus 3x is going to be 6x. And so this is just going to be x squared plus 6x plus 9. And again, if we were to finish off the rest of the equation, we're going to have plus 5 equals 0, plus 5 equals 0. And we can probably start seeing now the similarities that occur. So what we end up with is we end up basically recreating the original equation, right? So if we look at what we've got in the original equation, we've got an x squared. We've ended up with an x squared. And also in our original equation, we've got a plus 6x. We've got a plus 6x. So they're both correct. And obviously we've got the plus 5 and the plus 5. We've got this pesky plus 9 hanging around. And we don't want that, right? We don't want this plus 9 to be here, because what we can see is at the moment, these two versions of the equation aren't the same as each other, right? Because we've got this extra plus 9 hanging around. So what we see we need to do is we need to go back to our completed the square version, and we need to subtract 9 from it. And therefore, we'll end up subtracting 9 here and subtracting 9 here. And we can then simplify this because those 9s will then cancel, and we end up with x squared plus 6x plus 5 equals 0. So what we can see is this line here, this line that this new equation is the completed square version of the above original quadratic equation. And we could simplify this slightly, right? Because we know minus 9 plus 5 is minus 4, and so we would finalize this by saying x plus 3 squared minus 4 equals 0. And this would be our completed square version. And we can now rearrange for x, can't we? Because we know x plus 3 squared, we can add 4 to both sides. So we can get x plus 3 squared equals 4. And we can then square root both sides. And so x plus 3 equals plus or minus the square root of 4, which is just going to be plus or minus 2. And finally, we can subtract 3 from both sides. So x equals minus 3 plus or minus 2. And that'll be our answer. So that's a brief intro to completing the square and why we do it, right? It's because we end up with, the thing to always remember is we end up with this pesky extra term coming through. And so we always subtract that to avoid changing the whole value of the left-hand side of the equation. Right, moving on to the final version, factorising. So I've done a simple example here. All we need to do here is we want to get it into the format of 2 brackets like that equals 0. And I know that to get x squared, I've got to have x here and x here. And to get 5x, well, I know that whatever I put here in this box and whatever I put here in this box, well, I'm gonna multiply x by this box, and I'm gonna multiply this x by this box, and so I'm gonna end up with something x plus something x equals 5x. So I've got to think of 2 numbers that add together to get 5. I also know that I'm going to have to multiply the 2 boxes together, right? I'm going to have one box times another box, and that's going to give me my new number, right? That's got to give me 6. So I've got to think of 2 numbers that times together to get 6 and add together to get 5. Well, I know those 2 numbers. They're going to be 3 and 2. And so that's how we can use factorising to, again, solve quadratic equations, right? Because I know that, therefore, if I just focus on the left bracket and I decide to make the left bracket equal to 0, well, therefore, the whole left-hand side equals 0, right? Because 0 times anything is just 0. And so what does x have to equal for this bracket to be 0? Well, something plus 3 equals 0. So I know, therefore, that something has got to be minus 3, right? Because minus 3 plus 3 gives me 0. If I look at the right-hand bracket and I focus on making this equal to 0, I know that something plus 2 equals 0, and therefore x has to be minus 2, right? Because minus 2 plus 2 gives me 0. So that's a brief intro to all of our three main topics on solving quadratic equations. Let's go and look at one example. So let's do this with the quadratic formula. So in this case, I'm going to imagine there's basically a 1 in front of this x squared, right? This is the same as multiplying it by 1. So in this case, a is going to be 1, b is going to be 10, and c is going to be 24. And so I do minus 10 plus or minus the square root of 10 squared of 100 minus 4 times a times c, which is going to be 96, all divided by 2a, so 2 times 1. Well, that just gives me minus 10 plus or minus the square root of 4 Square root of 4 is 2. And that's divided by 2. Well, that means that I'm either going to have minus 10 plus 2 to get minus 8. Minus 8 over 2 gives me minus 4. Or I'm going to have minus 10 minus 2. Well, minus 10 minus 2 is minus 12. And minus 12 divided by 2 gives me minus 6. So they are my two values for x. We could do the same thing again, but we could complete the square, right? So let's do the same thing, the same question, but we'll do completing the square instead. So again, I'm going to have my brackets like this with my square here. And instead of x squared, I have x, and I halve this number. So instead of 10, I have 5. And I know that when I expand these brackets out, I'm going to get an extra term hanging around, which is going to be 5 times 5. So I've got to subtract that. And that means, therefore, that that this whole thing now represents the first two terms. And obviously I'm going to have my plus 24 on the end equals 0. Well, I know that minus 25 plus 24 is just minus 1. So I end up with x plus 5 squared minus 1 equals 0. And therefore x plus 5 squared equals 1 if I just add 1 to both sides. If I square root both sides, I get x plus 5 equals plus or minus, the square root of 1 is just 1, so it's just plus or minus 1. And I then get, if I minus 5 from both sides, I get x equals minus 5 plus or minus 1. So obviously minus 5 plus 1 gives me minus 4, minus 5 minus 1 gives me minus 6. So again, we've got the exact same two solutions using a completely different method. Finally, let's do method 3, right? So again, we've got x squared plus 10x plus 24. Well, in this case, I want two brackets. I want a bracket here and a bracket here. And I'm going to set that equal to 0. Well, I've got to think of two numbers, right? I'm going to have x and x here. I've got to think of two numbers that add together to get 10 and times together to get 24. Well, I know those two numbers are going to be 6 and 4. 6 plus 4 is 10. 6 times 4 is 24. And so if I focus on this first bracket, making this first bracket equal to 0, I know that x has to be minus 6. If I then focus on this second bracket and I want to make this second bracket equal to 0, I know x has to be minus 4. And so again, we end up with the exact same two solutions. And that's how we can apply any one of those three methods to solving our quadratic equations.